Anyway, 22 on 142. So it says the distance from the center of a regular hexagon to a vertex is 15 centimeters. Find the area of the regular hexagon. Okay. So it's six-sided figures. Okay. So from the center out to one of the vertexes, that's what they're talking about. And it says the vertex is the distance from the center to the vertex is 15. So that's what they've given to you, and they want to find the area.
So what number are we on?
22 on page 142. Now, the area of this formula is 1/2 the perimeter times the, they call it, I forget what it's like the height, but that isn't the word that they use for it. But it's this distance right there. It's that distance right there. It's the perpendicular to one of the sides, and that's the H. This is that H. I forget, it isn't height, but it's. So what you have to do is you have to calculate that height, and then you have to calculate what each one of those, each one of these are. You have to do this A and that height. Well, if you, a six-sided figure, the vertex angle, this, if you can figure out the vertex angle and figure out the angle right here, then you're able to get the H, and you're able to get half of A, and then you can get A. Does that make sense? You see what I'm going to do? Okay. So the vertex angle is n minus 2 times 180 all over n. So this is a six-sided figure. 180 over 6. So that's 30. And then you have times 4. That's 120 degrees. Now, just so that you kind of, you know, if you look at this angle right here is the same size angle as that one that's in green. In other words, that bisects that. So if this total angle is 120, then this has got to be 60 degrees. See, because the red angle here and the green angle are equal, and the vertex angle is 120. So it makes that angle 60. Well, then you know the distance on that black dashed line is 15. That's the hypotenuse. So the length of the green line the height is going to be the square root of 3 over 2 times the 15. Side opposite the 60-degree angle is the square root of 3 over 2 times the hypotenuse. Now, 1/2 of A,
Professor, which side would that be? Not the base, but the opposite side?
it's that dashed green line. This is the height right here. And 1/2 of A, which is this right here, this one right here, is going to be 1/2 of 15. So A equals 15. Now we're ready to calculate the perimeter and the H. So the area is 1/2, and the perimeter there's 6 times one of the sides, and then times that H, and H was the square root of 3 over 2 times 15. So that's 3, and then what you'll have is 3 times 15 squared, square root of 3 over 2. That's what the area is. So it's 3 times 15 squared divided by 2 times the square root square root of 3. And 584.6. Something like that. But you see, the reason or why we're doing it the way we did it? Okay. 24. It's telling us that we have an equilateral triangle, and then the altitude cuts the base in half.
Professor, before we go on, how did you come by the perimeter of that hexagon?
I took the formula is this right here.
Mm-hmm.
Then I plugged in the 1/2. That's
Mhm.
this. Then there's 6 sides, each of them 15 long, right? See, we found out that A was 15. So there's 6 of those going around, right? That gives us the perimeter. And then the height is this right here, and that's this thing right here. So that's 3 times, this is supposed to be squared. 3 times 15 squared, square root of 3 over 2. Okay, this one, 24, equilateral triangle. So that means all three sides are equal, and then what has to happen is every angle has got to be 60 degrees, right? Because there's 180 degrees of the triangle, all the equilateral says all the angles are equal and all the sides are equal on an equilateral. Then what they're doing is they're saying that the height, and the height has to be perpendicular to be defined as a height, and it bisects the base. So then this equals this. So if the sides are S, then this is S over 2, and this is S over 2, and this is the height. So use this back to find a formula for the area. So they want to find the formula for the area, where the area is equal to 1/2 the base times the height. Small letter. So what we have to do is we have to get the height in terms of S. Well, in a right triangle, where you have a 60-degree angle here, this height is the square root of 3 over 2 of the hypotenuse. So if we plug into this formula, 1/2, now the base of the equilateral triangle is S, and the height is the square root of 3 over 2 S. So the area equals S, well, I'll just square it.
That's squared.
Yeah, that'll do it. All right, the square root of 3 over 4 S squared. And that's writing the area in terms of, find the area of the following equilateral triangle in terms of S. So that's in terms of the side S. So we've done it in terms of the side S. So 26. Okay, this is an 8-sided figure. Oh, no, I don't know. I don't know if I can make this look decent. Kind of close. And what they want, vertice to vertice, and they want this, and this goes through the center. So this is the center, and they call this V. Now, in the instructions, it says use the result from problem 25. So we're going to have to figure 25, which is your problem. We'll do it. So we can draw this. very good proportion. They're saying this, that vertex to that vertex. None of those sides are supposed to be equal. And they're calling this D. So what is that distance on that 8-sided figure? Well, it's going to be this is going to be a parallelogram. You know, this thing it's a trapezoid.
Mm-hmm.
Okay. And this side's going to equal this side. And it's going to equal that side too.
Mm-hmm.
And what we got to do is we got to try to figure out 25. That's that. Find the formula for the distance of the sides of the octagon in terms of the length of one side x. So each one of these are x. So we got to find that distance in terms of x. Well, anyone got any idea? There's going to be a height, this trapezoid, that's going to be there, right? And it'd be nice if we could figure out this angle right here. And this angle. And they'll be the same whenever we figure it out. So what we can do is we can find out this angle, which will be the same as this angle, right? And that's the vertex angle is equal to n minus 2 times 180 over n. This is 8-sided, so it's 8 minus 2 times 180 all over 8. So that's 6 times 180 over 8. So just, if we can make it a little bit simpler, we could go 4 and 3, right? And then 4 will go into 18 even if you want. 4 fours are 16. Is that right?
540 over 4.
15. 135 degrees. Okay. So this is 135. This is 135. And so if we take the green angle there is going to be the sum of the angles of the trapezoid are, let's see, I want to figure out the angle, that angle, I'll call it C.
Those are 45s.
So it's going to be n minus 2 times 180 minus 2 times 135, right? All over 2. N minus 2 times 180 is the sum of all the angles. You subtract 2 135s out and divide it by 2. So it's 8 minus 2. What is that? 270. this is 6. Eight minus 270.
It's also 270.
Is that right?
Mm-hmm.
And that's, something's wrong. What is that? Should come out to be 60 degrees. Right. What did I do wrong? The sum, this is the sum of the angles, right? And it'd be 8. No, it's 4 minus 2. 8. 4 minus. Because it's 4 vertices. That's what.
All right, 4 sides.
So it's 4 minus 2 times 180 minus 2 times 1. So 2 times 180, let's see, and this is all over 2. Right? And then it's 180 minus 270. Oh, I didn't. It's 180 minus 135. And then you got 45, right? Yeah, see when I divided, this will divide into this, and it has to divide into both of them. 45 degrees. So Vincent, you said 45 degrees.
Mm-hmm.
Somehow you.
That was just dumb luck.
Okay.
I was going off the 90 at the top of the track. That's
Okay.
why, leaving 45 on the other.
Okay.
And 90 for that triangle. Could have been any other way.
So that means this is the hypotenuse. So it's x over the square root of 2, right? This side right here is x over the square root of 2. Because on a something that has 90 and 45, if it's 45, it's 1 over the square root of 2 and 1 over the square root of 2, isn't it? So that side is the square root is x over square root of 2. This is x over the square root of 2. So, and then this distance right here is x. So d equals x plus 2 times x over the square root of 2. It's 2x over the square root of 2. Now you always rationalize, you don't leave that in the denominator, so you rationalize it. So this is x plus 2 square root of 2 all over 2, right? X plus the square root of 2. Now did I do that right?
So the book is showing an additional x. X plus
because
x.
I forgot to put this x in.
Okay. There
Okay,
you go.
all right. So that's that distance. So now back up here, we've got that. This side is x, I don't know, I guess plus square root of 2x. And this side is x, right? So v is going to be the square root of the sum of those two, right? Is the square root, because it's a squared, it's this side squared plus this side squared equals this side squared. So v is going to be the square root of those. X squared plus x plus the square root of 2x, the quantity squared. This is x squared. When you square a binomial, it's the first term squared plus 2 times the product of the first times the second. Well, that's going to be the square root of 2x squared. And then the last term squared is going to be 2x squared. This was supposed to be x squared, by the way. So first, see this thing right here is expanding this, and it's the first term squared, which is right there. Then you take 2 times the product of first term x and the square root of 2x, so that makes you x squared square root of 2. And then the last one is this term squared, where you square root of 2 is 2, and you have x squared. So what I have is I have 4x squares, don't I?
Yes.
That's 2 square root of 2x squared. Now, this is actually x squared times 4 plus 2 square root of 2, and you're doing the square root of that. So you can square root x squared. So the x squared comes out as an x. And you have the square root of 4 plus 2 square root of 2. And that's what b is. Gets kind of complicated.
Couldn't you take the square root of the 4?
Yeah, but the only thing is it has to be a product to get it out.
Okay, gotcha.
In order to take square roots, you have to have a product. And then you can take the square root of the product, but you can't take the square root. You can't take the square root of terms of a sum. You know. I know you understand, but you can, if you have AB, you can do the square root of A times the square root of B. But if you have the square root of A plus B, can't do that. But this is not true. Okay. The applications, these are a little bit easier. Gonna be a lot easier. 32 says a baseball diamond is square that measures 90 feet on a side. How far must the catcher throw the ball from home to the second place to pick off the runner? So if you grant me that that's a square, and it's 90 feet on the side, so what do you, it's this distance right here, right? It's a squared plus b squared equals c squared, right? The distance equals the square root of 90 squared plus 90 squared. Square root of 2 times 90 squared. And that's just a calculator problem, right? $34. It says 2 bolts leave a dock at the same time. One heads due east, third at 20 mile per hour, and one heads due south at 15 mile per hour. How far apart are the 2 boats after 45 minutes have elapsed? So one goes east. How was that done? East is to the right, isn't it?
Mm-hmm.
And then one goes south. Yeah. This one travels slower speed, don't it? And this is 20 mile per hour, and this is 15 mile per hour. And if they're like that, this is 90 degrees, right? And then they want to know the distance they are apart. Wow. They want to know that distance. And they say they go 3/4 of a mile. So then 3/4 of an hour. So 3, God dang it. 3/4 of an hour. 3/4 of an hour. So the distance here, right there, is going to be 15 times 3/4, right? And then the distance there is 20. Now this one is 15 miles, right? This one don't come out so nice. And then that distance across there, let's see, I'll just call this one H, is going to be the square root of the 15 times 3/4 quantity squared plus 15 squared. And then you just put it in your calculator, right? What'd you get for that? Or do you want me to put it in there? Second square root. Bracket. And 75.75 will be the same as 3/4, right? And it's going to be accurate. So then bracket that. Then plus the 15. Oh, dang it. I gotta square it. I think I do it right here. Plus 15 squared. Is that what you got?
That's it.
36, it says a conveyor belt is to be set up to move bundles of shingles up to a roof if the edge of the roof is 10 feet above the ground. So 36. Well, what we can do is wow. So this is, I'm going to get it right yet. This is 10 feet, right?
Mm-hmm.
And then this conveyor belt, it can't have more than 45 degrees. Well, the 45 degrees angle would be that'd be the angle at the base, and if you want to have the shortest distance, you'd want to have a 45 degree.
So that triangle will be 45, 45, 90, correct?
Yeah, that's what you,
And that means the base will also be 10 feet, correct?
yeah.
Okay.
So this is the ground. So like you say, this has got to be 10, and this is a 9-degree angle. How far away from the house will the bottom of the conveyor be placed?
10 feet.
10 feet. I mean, I think that's the way it is. The edge of the roof is 10 feet above the ground. Conveyor can,
They also want to know how long the conveyor is. That's A squared, B squared.
oh, the conveyor belt. Okay, that's the first thing is.
That's easy enough. Square root of 200.
Yeah. Well, the other way you could do it is the ratio is 1, 1, and the square root of 2. So it's 10 times the square root of 2. That's it. The belt is that long. Feet. And then that was one question, and the other one, how far away from the house, bottom of the house, that was 10 feet.
Yep. That way works great too.
Okay. 5? Yeah. Yeah. Okay. I think that the rectangular field measures 235 by 240. How much shorter would it be to walk diagonally across the field than to walk the two sides? That would be, that's pretty easy, right? Just the square root of those squared. 38. You know, you have this rectangular field. Oh boy, we'll pretend like that's rectangle. In the diagonal, right? And then supposedly all of these are this. And they want to know this distance. When this one is 325 and 240. How much shorter? Okay. So what you do is you would take the diagonal, which is the square root of the 240 squared plus 325 squared. And then you would take the sum of 325 plus 240, walk on the edges, and subtract this, right? And that would be how much shorter it is. plus 325 minus the second square root of 240 squared plus 325 squared. Did you get 160?
161.
Yeah, 160.9. So it's approximately 161. It says the figure is showing the center of the pulley is 11 foot 8 inches above and 18 foot 3 inches to the right of the center of the other pulley. Find the distance between the two centers to the nearest inch. So that's just,
Converting everything
Yeah.
to inches first.
yeah.
And doing the math.
Mm-hmm. I think you can figure that out, right?
Sure can.
And 42 19-inch TV screen measures 19 diagonally across. If the screen is about 4 inches wider than it is high, find the dimensions of the screen. So what you're going to do is the diagonal and you're assuming it's a rectangular screen. And it's 19 inches here. And it says 4 inches wider than it is high. So you'd say x plus 4 and x, right? Then you just have 19 squared equals x plus 4 squared plus x squared. And you find that. X squared plus 8x plus, that's 16 plus x squared, right? So you get 0 by itself. 2x squared 8x plus, and then at 19 squared, what is 19 squared?
380. No.
361.
361? So it'd be 16 minus 361. Now that one, to find it, you're going to have to factor it, right? Two numbers times itself is, and then it'd have to be a difference of 8, right? Or you'd be doing x and x with a plus and a minus, and then you're going to have a 1 and a 2 in these locations. And then you're going to have something in here that are factors of this. 1 and 3, 45. 2 don't, 3 don't, does it? 3 don't. Yeah, 3 does, doesn't it?
He does.
3 is 1, 1, 5. But that won't work, won't have a difference of 8.
No, it's got to be much
5,
closer.
so you're gonna have to find it and then find those things, right? Is that just right? And you'll factor it in. 5, I don't, you wanna proceed 5 times what? 69?
Even those factors are too far apart, so it's not going to
Yeah.
equate to 8.
So
Be like 10 and something.
10 won't
11
work.
something.
10 will factor. I don't know where it's at. What?
Oh, you know what? Monday's another
First I
day.
got was 9 and 15.
Did you?
9 and 13? Is that it?
No, I think it's 9 and 13. I got 9 and 15, but I know that isn't right. But somewhere around it.
40. 9 times 5 is 45. Well, it can't be,
9 times 15. But that looks incorrect.
that don't come out.
15.
90.
All right, my friends, I will see you all on Monday.
Okay.
Have a great weekend.
Too.
All right, but you see how
Yeah, it's a lot.